Okay, we're now going to take a look at question 5 from AS paper 2 Jun2006. First question asks to explain the meaning of the term diffraction. Diffraction is essentially a wave property, and diffraction is the spreading of waves as they pass through a gap or around an obstacle. Okay, very important. It's the spreading of waves. Okay, so diffraction is the spreading of waves through a gap or around an obstacle. That's quite a lot for 1 mark, and some other papers you may get more marks for that. It now says to describe a laboratory experiment to demonstrate diffraction using a single slit or aperture of adjustable width. Your description should include a labelled sketch of the apparatus first of all. Now, because it suggests there a single slit, I would probably go with a light source here, but it's not necessarily that. It could be a ripple tank demonstration of it, but if we consider the light source, what we've got first of all is, okay, we have a bulb, okay, a single slit and a screen, and we'll just label those. This is the screen, this is the adjustable slit, and this is the bulb, which is our light source. You may want to put in a filter in there, but I don't think that that's necessary at this point. If you look at the examiner's mark scheme, they just say a sketch, ripple tank or optical demonstration which has a wave source and a slit and viewing arrangement. So the screen is the viewing arrangements, the adjustable slit is the slit, and the bulb is the light source, the wave source. The next part of the question is probably much more important in some respects, because it's a description of the results illustrated with sketches to show the effect if the width of the slit or aperture was increased. Now, so essentially what happens is that the narrower the slit, the greater the diffraction effect. So that if you have a narrow slit, when those waves approach, what happens is we get a lot of diffraction, and try and make sure that the wavelengths are the same. Okay, so that would be the obstacle there with the gap at that point. And then when we have a much wider gap or wider slit, then what happens is these waves, as they approach that, well, the waves here will go straight through. Again, ensure that you have equal wavelengths on either side. It might be better to measure that a wee bit better, and then we get a little bit of diffraction around the edges in this instant. So lots of diffraction here, and possibly even take that around a little bit further, more diffraction here. So this, and just make sure that you label these as the wide slit and the narrow slit. Okay, so we get greater diffraction is observed whenever we've got a narrow slit. The slit must be in the order of magnitude of the wavelength in order to get this appreciable diffraction. And over here then the waves travel straight and then diffract at the edges as they go through. State the condition for optimum diffraction. Well, I've just mentioned that really. The size of the slit must be equal to or less than the wavelength. So the slit must be approximately equal to the size of the wavelength or slightly less than it. Okay, part C is about a diffraction grating, and we don't need to do that because that's no longer on the specification, so I'll not finish with that one.